we've already seen that one way to think of multiplication is as repeated addition. Well, today we're going to look at what happens if we do repeated multiplication. In that case, we get exponents. An expression in this form, where we have a regular sized number or variable, and then we have a smaller number or variable written as a superscript, can be used to represent multiplication. The base, which we wrote as a, is the value to be multiplied, and the exponent, which we wrote as m, is the number of a's being multiplied. We can read the expression as a to the power of m. Let's look at some of the powers or exponents when our base is 3. When working with repeated multiplication, we always start with 1, because that's the multiplicative identity. We could try starting with 0 instead, but if you multiply 0 by anything, you just get 0. So all of our exponents would be 0, which wouldn't be very interesting. So instead, we start with 1. 1, in fact, is 3 to the power of 0. In fact, anything to the power of 0 is 1, because this is where we start from before we've multiplied anything. Now, from 1, we multiply by 3 and get 3. Multiply by 3 again, we get 9. We multiply by 3 again, 27. Multiply by 3 again, we get 81. Now, each of these can be written in exponent form instead. So 3 is 3 to the power of 1 because we multiplied by 3 once to get there. 9 is 3 to the power of 2 because we multiplied by 3 twice. 27 is 3 to the power of 3 because we multiplied 3 times. And 81 is 3 to the power of 4 because we multiplied by 3 4 times. Now this is all useful for going forwards along this chain of powers of 3. But what if we want to go backwards? What if we want to go the other way? Well, in math, whenever we want to work backwards, we always need to do the opposite or inverse operation. And the inverse of multiplying by 3 is dividing by 3. So we can work along this chain by dividing by 3 to go backwards. So if we look back at 1, we can work backwards from there and have 1 divided by 3, which is 1/3. Divide by 3 again, we get 1/9. By 3 again, we get 1/27th. And divide by 3 again, we get 1/81st. Now, what exponents do these represent? Well, because we're working backwards here, we're going to have negative exponents. So 1/3 is 3 to the power of -1, 1/9 is 3 to the power of -2, 1/27th is 3 to the power of -3, and 1/81st is 3 to the power of -4. Let's practice writing out some expressions using exponents and what we call expanded form, where we just write out all of the multiplications. So, 3 to the power of 4. That means we're multiplying 3 4 times, so it's 3 times 3 times 3 times 3, which we can see from our chart above is 81. 4 to the power of 3 on the other hand, and keep in mind it does matter which number is which when we have exponents. This is 4 times 4 times 4. Our base says which number we're multiplying, and our exponent, 3, says how many times we multiply it. This is 64. 11 to the power of 2 is 11 times 11, which is 121. If we have a base that's a variable, we're not going to be able to evaluate it unless we know what the variable is. However, we can still write them in expanded form. So x to the power of 6 is x times x times x times x times x times x. Y to the power of 5, y times y times y times y times y. A to the power of 4, a times a times a times a. Now if we have an expression in expanded form, we can also write them in exponent form. So 7 times 7 times 7. 7 is the base because that's the number being multiplied. And the number of 7s is 3, so that's our exponent. 12 times 12 times 12 times 12 times 12 is 12 to the power of 5. And x times x is x to the power of 2. Now we saw earlier, when we had negative exponents, we got to those values by dividing. So if the exponent is negative, we need to repeat the inverse of multiplication, which is division. If the base is an integer, this usually results in a fraction. If we have 3 to the power of -2, we need to start with 1 and divide by 3 twice. The most convenient form to write this in is 1 in the numerator and 3 times 3 in the denominator. So this is 1/9. 2 to the power of negative 5 has 1 in the numerator and 2 times 2 times 2 times 2 times 2. Because we've divided by 2 5 times, this is 1/32. 10 to the power of negative 3 is 1 in the numerator and 10 times 10 times 10 in the denominator, which is 1/1000th. X to the power of negative 4 is 1 in the numerator, x times x times x times x in the denominator. Y to the power of negative 2 is 1 in the numerator and y times y in the denominator. And b to the power of negative 7 is 1 in the numerator and b times b times b times b times b times b times b in the denominator. Remember, in a fraction, the denominator is performing our division for us. So even though we're writing multiplication in these denominators, those numbers are actually being divided. We can also go the other way. So if we have 1 over 6 times 6 times 6, this is 6 to the power of negative 3 because we're dividing by 3 6s. If we have 1 over 9 times 9 times 9 times 9, we're dividing by 4 9s, so 9 to the power of negative 4. If we have 1 over y times y times y times y times y times y, this is y to the power of negative 6 because we're dividing by y 6 times.